And here, this is what we see, a complete menu in fact. It says wells, logs, core, and other databases. So on the one hand, we can click on this one here, wireline logs and geologist reports. So this will be all the paper logs. Then scanned wireline logs, we can click on that. So that will show only the wells with logs that have been scanned into TIFF files. So you could read that with your software, or you could then read it otherwise with Schlumberger Blueview, or I imagine the other service companies also have free software. Looking down here, there's also the core library, by the way, and scanned core analyses. Other things we'll be looking at, though, later, most people, well not most, a lot of people don't know where this is, the search for brine analyses in Kansas. So one critical aspect of doing traditional log analysis is to have a number for RW. What is the resistivity then of the formation water? This can either be estimated directly from the logs, as we shall see, or we can get a measurement then, hopefully, from a brine analysis in the area. So a lot of different sources of information we'd use in connection with the logs. Okay, here we are again. We clicked on, we said, let us look at McCoy Petroleum Bain Trust 131 and see what's available. So in terms of paper copies then, for sure, we got the geologist report, and then we got some Halliburton logs here, microlog, long space sonic, spectral density neutron, and also dual induction lateral log. And it gives the top and bottom then of those particular sections. By clicking here, then we can finally find out in detail then what's available to us in terms of the formats. So here we are, we click on that. We can view the tops for the well. You will find in many cases then tops are being put, and you'll notice sometimes that you'll see 3 different tops which all disagree with one another. So at various times there have been projects involved where people have gone and picked tops, and so you may see some different opinions of the same top. Okay, log scan files, well there they are. Still in the same well. Download the scan. So on any of those you could click the scan and then it would show up on the desktop of your laptop or your main computer, and then you could print it out directly. Otherwise, we see this. Digital wireline log, LS file available. We can download the log, we can view the log header, or we can display using Gemini. Very often it's useful actually to view the log header to see what's there. Because sometimes you'll say you downloaded it and you said, I'm ready to go, and you found that the only log available to you was a gamma ray log. And you said, that was a lot of work just to get a gamma ray log. So if you like, the view the log header is kind of a sneak preview to see what you're going to get if you download it. Display using Gemini. Gemini is a web feature, uses Java and so on, where it will immediately access the digits here and it'll give you a quick look display. So that might be another aspect. You say, well, okay, looks like we got some logs, but I want to have a quick look to see what's there and see which kind of interval I'm going to work with. So probably 1, 2, and maybe 3 if you really want to work with the logs. So, same well, here we are, Gemini. This is a project that was done maybe about 10 years ago. It was a DOE-funded project, and a variety of tools were produced, of which one of them is here. And it's free, so there's no cost associated with it. And it will simply give you, in this case, what we see is here. Here are the logs it was able to read. It said, okay, it's checked out the LS files, and it saw a gamma ray, an SP, it saw some resistivities, and from the colors, here we are on track 1, red, there's the gamma ray there. We're seeing green for the spontaneous potential, and then we're seeing some resistivity logs over there. So this is the interval that we've been looking at so far. Right there, there is the lower Morris sandstone, the keys, there's the top and there's the bottom. And so we can say, okay, I want to go beyond simply looking at these and actually work with the digits to calculate how much oil or gas is in the section. Something else that's showing up too, and it's kind of showing the start to the future, is over here we have an image, and that image is simply based on the gamma ray log. So I'll be talking about that later on when we move from digits and wiggles to the notice of images to actually show things as if you had a picture of this as an outcrop. So right here you can see that it's really a grayscale presentation of that gamma ray log going from white, which would be 0 on the APR scale, to black, and I think it's about 150. So you can see a sandstone here, and you can see the shales above, and here's some shaly sandstones, or shaly limestones even within the section. So it's kind of simulating in a way an outcrop. And that will mean that geologists, for example, who are used to looking at outcrop can get a very quick visual impression of what's going on. Now notice you say, well, looking at this well, I really don't see that this is an improvement on that. It's showing the same information. However, you might be looking at, say, 17 wells on a line. And by simply cutting and pasting these, I think it's easier to see what's going on looking at the image, because now it's making it as if it was a subsurface picture of the outcrop. So as we move into the digital world then, we have all sorts of other things we can do. On the one hand, we can simply present the information the same way as we're used to looking at as wiggles, or we say, well, now we've got digital form, we can start to move upwards. Just as, for example, when I've emphasized doing log analysis using spreadsheets, well, increasingly things are moving up to apps. You know, Java apps and so on, we're moving up in that direction as well. So in other words, as the digits come in, we'll be writing that to see if we can provide better information, as it were, to everybody. Okay, or, and this is our third option, download it onto a PC, unzipped and opened as a plain text LS file. So what will happen is if you download it, it's in zip format. And that is because some of these LS files are pretty big, so it'll take a long time to actually download it onto your laptop. But it'll appear as a zipped file. Now pretty much every laptop or computer that's given you has a piece of software as part of it where it'll simply allow you to unzip directly. So you're not looking at a high cost purchase of another piece of software. This is a pretty standard feature. It unzips the file and says, okay, it's plain text. So here we are looking then in a little more detail on that Bain Trust well. And again, these are the tilde signs breaking up the various sections. And this is the part I emphasize where sometimes you can run into a problem. This is the tilde C, the curve information. There's mnemonic. There are the units it was measured in. Here are the curve descriptions. This is the way it's supposed to be. Many times, though, they don't bother to put in the curve description. So you're left hanging there. Okay, what am I looking at? I'd say looking at things like Cali for caliper, gamma ray, that's pretty easy to guess. Sometimes, particularly for the resistivity logs, you might get some strange mnemonic and say, what? But you're clued in by the units. Anything that's a resistivity log then will be in ohm meters.